exponent rules, a concept that you know about, that you've had in pre-algebra, and then I think you'll be pretty good at. First of all, our essential question is, how can I simplify expressions involving exponents? And I do mean simplify because we're no longer solving equations. We're going to be simplifying things, just getting them into simplest terms. There are many ways to simplify the expressions. But first of all, we need to know what an exponent is. So remember that x to the 7th means I'm going to make this base, x is considered the base here, and 7 is considered the exponent. X to the power of 7 means I'm going to multiply x times itself 7 times. So here's x to the 7th. I have x times itself 7 times. Now, because of some unique things about the way exponents work, there are properties for how they can combine. And we're going to talk about proving some of these properties in class. That will be what's new. But what's not new is the properties themselves. So, we have 5 rules to get through today, but they will go quick. First of all, product of powers. So, if I have two things with the same base and some exponents, I can write them with the same base and simply add the exponent. So let's take a look at the problem. I have 7 to the 4th times 7 to the 8th. Since these have the same base, I can simplify this as 7 to the 4 plus 8, simply adding the exponents, and I get 7 to the 12th. Now, there's a very good reason why this works this way. We will learn about it in class, and it will help you memorize why this happens. Here, I have 3 bases. All of them are the same. Something that I need to remember about exponents is that if there is just one x here, this is x to the 1st. And that should make a lot of sense. Look, it's just one x. It's x times itself just once. So x to the 1st. So when I add these exponents together, I'm going to go 2 plus 6 plus 1. I get x to the 9th. That's what 2 plus 6 plus 1 is. And again, there's a very good reason for this. We will discuss it in class. Next rule, power to a power. So in this last slide, I had 2 powers multiplying each other. In this slide, I have a power taken to a power. This is the situation where you want to multiply exponents. So take a look here. I have a base of negative 6. And this base is being taken to an exponent of 2. But then this whole thing is being taken to an exponent of 5. So this is a power to a power. I have a power taken to an even greater power. I must multiply these powers to get negative 6 to the 10th. 2 times 5 is 10. So my answer, negative 6 to the 10th. Notice that I could actually do negative 6 to the 10th. It's going to be some really big number, so let's not worry about that for now. Next, this is a very weird base, y plus 1. Very weird base, but whatever. It's being taken to the 6th, and then this whole thing is being taken to the 2. So here's my base, and again, it's a weird base, but it's a base. I need to do 6 times 2, which is 12. So here's a more simplified expression, y plus 1 to the 12th. Just like rule 1, there's a very good reason for rule 2. That we'll talk about in class. Next, rule 3, product of a power. If I have something inside that is a product, in other words, multiplying, so if my base is made up of 2 things that are multiplying each other, and I have an exponent, I can essentially distribute this exponent in and get a to the m times b to the m. You can think about this as distribution of the exponent. So let's take a look at this example. I have 3 things actually that are multiplying in here, the 9, the x, and the y. So I'm going to distribute the 2 to each of these. So 9 squared times x squared times y squared. This is actually going to simplify a little further. 9 squared isn't too bad. 9 times 9, 81. So my final answer, 81, x squared, y squared. Next, negative 4 to the 2, z to the 2. I'm distributing my exponent in. Negative 4 is being squared. Also, z is being squared. Now, we must be careful. Negative 4 squared is negative 4 times negative 4. That's positive 16z squared. So you ask yourself, how is this any different than this one? And it's different because this is where students make the most mistakes, which gives them a frowny face and a small tear. Take a look at what's different here. Here, negative, inside parentheses. Here, negative, outside parentheses. Order of operations treats this negative like -1, and the square only gets distributed to what's inside the parentheses. And I must distribute the exponent before I worry about this -1 times the parentheses because of order of operations. PEMDAS, exponents comes before multiplication. So I must distribute in the square first. So -1 still outside. I have 4 squared, and I have z squared. Now, I have -1 times 16. 4 squared is 16, and then a z squared. What's -1 times 16? Well, that's -16 z squared. So notice this one came out negative because the negative was outside, but this one came up positive because the negative was inside, and I actually did need to square the -4, which canceled the negative. Whew, all these rules. Let's apply many of them at once. Use all 3. PEMDAS says order of operations should come first. So I'm going to distribute in the exponent. 2 squared is 4. X to the 3rd squared. This is a power of a power. And according to rule 2, that means I need to multiply. So this is x to the 6th. I still have this x to the 4th over here that I didn't deal with. Now take a look at what I have. This is a rule 1 situation. I have 2 things with the same base multiplying each other. That means add the exponents. So x to the 6th times x to the 4th is x to the 10th. This 4 doesn't really have anything to combine with. It's just hanging out outside. So here's my final answer. Wow, that was fun. Let's keep moving on. We have 2 more rules to get through if you're keeping track. Rule 4, quotient of powers. Look. Whoa, that was crazy. I zoomed in without knowing it. Wow. Here, I have a base to a power. I'm dividing it by the same base to a power. Now, think about it. If I had multiplication, I knew to add the exponents. Does it make sense that if I do division, which is the opposite of multiplication, I should subtract the exponents, since this is the opposite of addition? I think it makes sense. So let's do it. Here, the base, kind of a weird one, -3, but I need to subtract the exponents. So this is going to be -3 to the 3rd. This is an easy one to do. Let's just write -3 times -3 times -3. This is 9, positive 9, and times another -3 gives me -27. Here, do I have a quotient? Does it look exactly like this? No, it doesn't. So I'm thinking, let's perform a little multiplication before we go into it. First of all, x to the 6th can be considered over 1. And remember, fraction multiplication, top times top, bottom times bottom. This gives me x to the 6th over x to the 4th. And now I can see that my bases are the same. I need to subtract. This will be x squared. This is another one that there's a very good explanation for, even aside from this opposite property. When do you think we'll talk about that? Class, of course, because we're crazy people. Rule number 5, power of a quotient. These are the last 2 examples, and then we'll be done. Hey, remember this one that said I could essentially distribute the exponent in when I have a base that's involving multiplication? Same thing here. If I have a base that's representing division, I can essentially distribute this exponent to the top and to the bottom. And here's my problem. So let's look at the first one. The examples here are a little bit tricky because when we distribute 3 to the top and to the bottom, I should still probably write these in parentheses. 4x squared to the 3rd over 5y to the 3rd. Because now, looking at just the top, I have a situation where I need to distribute in this cube. So 4 cubed, 4 times 4 times 4 is 64. X squared cubed, this is a power to a power, so I want to multiply the exponents. And you can probably start seeing where these problems get tricky because I'm combining many, many steps at once. Great, we took care of the top. Now, let's take care of the bottom. I need to distribute this cube in to both the 5 and the y. 5 cubed, 5 times 5 times 5 happens to be 125. If you thought it was 15, you went 5 times 3, not 5 to the third. And then y cubed. This is my final answer, though I should always check to see if I can cancel some things, like, am I allowed to subtract these exponents? The answer is no, because their bases are different. So this x and this y, they are different bases. I cannot subtract the exponents. All right, one last problem, and then we're done. First of all, let's distribute this fifth to the top and the bottom. On the top, I have a power to a power. Multiply the exponents. On the bottom, just b to the fifth. And remember, you can think of it, if you want, like b to the first. Multiplying the exponents 1 times 5 is still just 5. Then I haven't done anything to this second fraction, 2a squared. Let's see, if I do top times top and bottom times bottom, I have a to the 10th. I have 2a squared b to the 5th. None of these combine because they don't have the same bases, so I just wrote it nicely in alphabetical order. I have one final step though. Look, there are 10 a's on top and 2 a's to the bottom. Remember, if I have a quotient, I need to subtract. So, what is a to the 10 over a to the 2? That would be a to the 8th over 1, if you want to think about it. It is on top of the fraction. So this is going to simplify, since I can simplify a to the 10th over a to the 2 to a to the 8th. Now there are no more a's on the bottom, and I'll give you perhaps a more intuitive way of thinking about that. Guess where? In class. But for now, you have gotten a great Mr. Gregory approved reminder of how to do all of these rules. None of these are new. You have learned all of these before in pre-algebra, and I know that because I tutor some pre-algebra students, and they had a very easy time with this because they were very good at it. So you used to be good at this. Just remember, in summary, if I have two powers that are multiplying, I want to add the exponents. If I have power to a power, multiply the exponents. If I have something like this, I can distribute. If I have division of powers, I can subtract the exponent. And just like I can distribute to multiplication, I can also distribute to a fraction. Done. Thanks for watching.